Hi, I'm Josh, and I'm the VP of Data and AI Architecture here at SEB. One of my personal beliefs, as well as one of the beliefs of SEB as an organization, is that AI is one more tool available at your disposal, with the ultimate goal for that tool, or really any other tool, being to achieve whatever outcome you desire, or plainly said, the best ROI for your investment. So with that said, today Sid, who is our head of AI, is going to give a demo built around the Databricks Agentic framework. The context is within healthcare, but a lot of what you will see can and does apply to other business verticals and industries. I hope you enjoy it. Here's Sid's recording.
How have we built an AI agent that is aligned to a specific industry and business-specific problem? How do we actually build it? And how does a tool like Databricks actually help in that progression towards building an AI agent? For a little bit of context on the actual demo, we've worked with a lot of different customers, and one overarching problem that applies to all the industries and verticals is they have data coming in from these, various formats and files, and it's not the same. It's not like a standard document that OCR can be applied because it has handwritten information. It's different formats that you're dealing with, so not always the same fields and everything like that. And there's broken pieces of context pretty much. And how do we get from this to actually performing programmatic or functions based on this information, which requires like some kind of form of structured input and structured data, right? So really this going from these completely ambiguous, unstructured formats into a destination structure. That's one core problem that exists pretty much in all different businesses if we're looking at it and looking at the possible use cases. And the way we applied it here is in, an EHR system that is trying to work with multiple different, insurance providers, that is helping the, offices file claims of insurance claims for their patients and the treatment that they've been receiving, their prescriptions, and helping augment that process, that system in the middle that helps the doctors. We wanted to take a system that wasn't really reliant on what is inside the actual claim application filing, and we wanted to take those details, extract and meet it at the destination, like extract these ambiguous and unstructured formats, and then taking it to a destination structure where we've making it like a apples to apples comparison, and we have all the claims details, the required information that we need extracted from these different forms of unstructured data. We also wanted a system that would be able to perform this automatic underwriting. When manual underwriting is required and on these systems, claims get overlooked or neglected or automatically bypassed. So having some way of having an auditing system as part of that EHR and through the filing itself, we can help prevent the number of times that this gets rejected at the time of actual submission to the claim provider. We also want to validate it against codes and billing codes associated with all of these different different procedures that are being filed. These are all the different things that we kind of tried to do. And as you can see, when we treat it with a regular AI workload where we're dealing with just a prompt engineering system, the amount of context that has to be passed back and forth, and the amount of things that are more systematic, that need a systematic set of validation to occur and actual specific actions to be taken, validate that those details, is a little bit more in this process. It's not your standard, straightforward, direct, throw the PDF at the model and see whether it comes back with the details or not. It needs further information to go off of to make sure that it's a tool that actually works effectively and coming back to that core point of delivering ROI for the business. Like, we created this like sample EHR to help process these different claims, and rather than going the traditional route of directly taking filling in this information, we'll just upload the file directly of the claim documents that are related to this. So this is like a PDF of all of the medical procedure documents. You can imagine the claim application itself, some of the doctor's notes, the prescriptions, whatever is present within this, right? Pretty much anything that was related to the procedures. And then we can go ahead and just throw this in. And so that kind of kicks off our process. So now our actual agents that are responsible for making the process I described happen are kicked off in the background. And to show you kind of what that looks like, I'll just flip to the Databricks view while this is running and show you how we kind of set this up. So Databricks has this framework called the Mosaic AI Agent Framework. What that really allows us to do is connect what a model is able to do just on its own through the general purpose model, so the general context and understanding that they have, plus purpose-built tools that we create that can help perform specific actions or help with specific context that is needed for the task at hand. So we've kind of split out this workload into a few different agents, and each agent knows its kind of responsibility and its job. It's been given that context, telling it what job it is and what it's meant to be doing, so they know when to trigger in what process. So you can imagine the first part of this process is first we need to extract the details from the actual given claim doc, right? And that's exactly what the first one is going to be responsible for. So another cool thing that I think is really exciting within the Mosaic AI agent framework is their ability to view the traces of the agent, so you can see how it's working in the background. And we won't get too in depth to it, but I'll just kind of explain how through that we can see how those tools plus that agent itself is working. So we actually see that there are a set of tools and there are a set of model calls that are being made. First, we're giving the model context on the available tools that it has. And one of those tools that it has available to it is the actual extraction process, right? Being able to extract the tool that is responsible for getting the data into an image format that can then be parsable, but then also having it do data extraction so it has both pieces of context to work off of. And by giving it context on that, it knows that, well, we need to call that tool and first get the data from that. And then it goes back to the model to ensure that that information has been extracted and then returned in a specific structured JSON format. So the first model call is responsible for actually deciding when the tool that needs to be called. And then we can see that that tool actually gets executed. And then the second model call is to then take the information extracted by the tool and then structure it into that JSON format or that structured output format that we're looking for that we can then work off of. So that was the first agent and how we interacted with that. The second agent, what it allowed us to do was to then validate whether making a model call here to first make sure that the actual agent, the output structure that the previous agent provided has all the information that we're looking for from it. And in this call, we see it's just making one model call. But and that's because it found out that the response structure is valid. We have all the relevant details we need. But if the model didn't have all the details that it needed from the previous agent, then it would go back and provide to the user saying, these are the information that it's missing before it can proceed further in this flow. So we given it access to that tool as well, which will help trigger to gather more details from the user as well. But as you can see, it's decided that that tool call is not relevant here because it has all the information it needs. And then the third agent that we created is the agent that's responsible for actually looking at the historical examples and the historical claims that have been filed that have similar information as to the one that's being processed here. So similar details to the Olivia Martinez's claim, and where maybe a similar procedures have happened or a similar incident has happened, and basically given both the details of that claim at a summarized level. So first, the similar case retriever is just the tool that is going to be retrieving all of the similar examples. And then what we see with the second model call is then basically validating whether the relevance of that claim itself and whether the output of that, how does the output of those historical claims affect the claim that we're processing now. And so by having that context of the historical claims plus the claim that we're processing now, it's able to come to a conclusion as to the kind of the next steps here and then tie into our last agent, which I'll explain in a bit. Then the last agent, what the last agent is responsible for is it's responsible for taking the similar claims that were processed and the resonance between those similar claims and the claim that we're processing now that the last agent provided. So what are the overlap and what are like the similarities both that it's seeing as well as the differences, and how do the similarities and differences affect that result of the what effect or have the weightage it would have on the actual previous on the claim that we're processing now. And it's taking that context plus it's also using the tool evaluate claim to help gather all of the different the different codes that would be somewhat responsible or somewhat relevant in the procedures that are being performed now, and then basically determine whether the codes that have been filed actually match the codes that should be filed, as well as check whether there are any missing codes that are not included in this process, and then if they aren't, including them as well. And then once that tool has executed, it's taking a historical claim context as well as the codes that have overlapped and are matching or potentially missing in the codes that it checked against. And then from there, it's deciding whether it needs to, and from there, it's returning one actual output format as to its final decision on the claim, whether it needs to be reviewed by a human, so keeping that human in the loop, or whether it's approved, or whether it's died due to some missing information. And so that's how we really tied this overall process together and orchestrated these different workflows. And so I think now we can kind of see a result of that present within our actual claim that we just processed here. And as we can see all those informations extracted from that are required for any claim processing. And we can also see what the AI decision here was, that it's saying that a reviewer needs to review this, and because of that there's no detailed policies that are there, and it's not able to validate the coverage under the policy number. So it's saying further review is required here. And so now it's giving me the option to proceed on this or not. And this is how we kind of helped augment these different workflows and helped tie together this agentic process. The other aspect that we can do from here is also show how we're leveraging a pre-built agent. So all of what we've shown so far are custom agents, but Databricks also offers a pre-built agent that we can embed in our application called AI Genie, which helps us work off of our data so all of these claims are getting processed and stored back in our data warehouse in Databricks, which we can then use for analysis or more of an enterprise search on, as we can see here. So something I can ask is, a very vague question that my boss might ask me if I imagine I was in the business, as what happened with that claim that underwent laser treatment last week? What were the details on that? And through that, this could be a number of claims, as you can imagine, but at least AI Genie can help filter this out for me and, get me the closest results that are there in the data warehouse against this information without me having to pretty much build anything, right? This is from scratch, working off of the context that it has in the data warehouse. And it's telling me the status of the two claims that kind of correlate to this. And the procedures that they underwent, and then also and it's saying how it relates to the coding that I was asking about, which is that laser-based treatment. So it knows that this code is related to laser treatment and is pulling the respective procedures as well. And again, as you can see in all of these different examples, it ties back to the context that we're giving and the actions we're letting the system perform by giving it those set of tools that it has available to work off of. And I think that the AI agent framework that Databricks introduces through Mosaic has been really an easier way to democratize that ability and give a framework that we can tell the model, these are the different tools that you have available and what each of those tools do. And then also see the orchestration as it happens with that tying back into ML flow and evaluating our agents and seeing how we can tune them and make it better so they're more effective and deliver that ROI that we're looking for in the business.
I hope you enjoyed this video, and thank you so very much for watching.